Good evening, everyone. Welcome back. In the last session, we discussed about what is software project and why we need to develop a software project and what is the architecture of a software project, what layers will be available, what is front end, what is back end, what is database, and what are the different technologies are available in order to develop a software application we have seen. Then we also discussed about different technology stacks that companies are going to use to develop a project. And we understood what kind of teams will be available in the project and what is the purpose of that team, what are the roles and responsibilities of that team in the project we discussed. So mainly here we discussed about what are the roles and responsibilities of operations team in the project. So as a DevOps team member, what we need to do in the company that we discussed here. And also that we also discussed what all the main skills that we should know in order to become a DevOps engineer. What are the skills required to become a DevOps engineer? Those points also we discussed in the last session. Fine. Today, let us understand what is DevOps and why DevOps. What is DevOps and why DevOps? Let us try to understand this point today. So first thing here, DevOps is the combination of two terms, guys. One is development, another one is operations. So when we say DevOps, it is equal to development plus operations, guys. For every software project, development team will be available who will take care of the coding part. Once the coding is completed, we need to deliver that code as one application to the client. So that's where operations comes into picture. Development team plus operations team will work together. So the process of making development plus operations smooth in the application is called DevOps. So this DevOps is not a new technology in the market, guys. It's not a programming language. It's not a new technology. Then what is this DevOps? This DevOps is a culture that companies are going to follow this DevOps culture. So we can say DevOps means it is the combination of development plus operations. DevOps is a culture, and we can say that DevOps is a process. DevOps is a process, and DevOps nothing but set of best practices. DevOps means set of best practices that we are going to follow. So as discussed, in a project, multiple teams will be available. Development team will be available, testing team will be available, and operations team will be available. So then why this DevOps process comes into picture, what we need to do as part of this DevOps. So we can say DevOps is a culture, and we can say it is a process, and we can say DevOps nothing but set of best practices. And why we need to follow this DevOps process. This DevOps is used to establish the collaboration between development team and operations team. So in a project, dev team is working, that a dev team set of team members will be available. Those team members are doing some coding for the project. Okay, set of team members will be available. We can call it as a dev team, and that a dev team is going to write the code. Right, all their code will be available here. Application source code will be available. We cannot give the source code to the client directly. Okay, whatever the dev team is doing, that code we cannot give to the client directly because clients cannot understand that source code. Okay, so we need to convert that source code into one executable application. We need to convert this source code into one application, guys. So that's where operations team comes into picture. Okay, development team is available. They are writing the code, and that code we need to deliver to the client. Okay, how we need to deliver that code to the client? Directly we cannot give the code to the client. So we need to deploy that code, and we need to perform some operations on the code. Then only it will be converted into application. Who is going to do that work, guys? That's where operations team comes into picture. Operations team, nothing but DevOps team comes into picture. This DevOps team is going to perform operations on the project, and they are going to convert that source code into one application. And finally, operations team is going to deliver that application to the client. Okay, so here this process is called build and deployment process. Okay, so developers are writing the code. That code we cannot give to the client directly. We need to perform some operations on that code. Then only that code will be converted into one executable application. Then only code will be converted into executable application. Then we need to deliver that application to the client. So dev team is available, and here ops team is available. So in a project, dev team will be working and operations team is working. Two teams are working on the same project. Then there should be some collaboration between development team and operations team. So that's where this from the development team, this dev, from the operations team, this ops came into picture, and we are calling it as DevOps. So DevOps is a culture, DevOps is a process, and DevOps is nothing but set of best practices that we are going to follow. So why we need to follow this DevOps culture? To establish collaboration between development team and operations team. What they are doing, what code they are doing, okay, by using which technology they are doing the coding. That technology, that softwares we need to install in the system, and we need to run that application, and we need to deliver that application to the client. So there should be some communication between development team and operations team. That's where this DevOps concept came into picture. So what is the main aim of this DevOps, guys? The main aim of the DevOps, that is to simplify and automate and speed up application build and deployment process with a high quality. So whatever the code is done by the developers, we need to simplify the operations of that application. We need to simplify the operations, we need to automate the operations, we need to speed up, and we need to deliver the application. Okay, whatever the operations we are doing, we need to simplify those operations, and we need to automate those operations, and we need to speed up those operations. So because of these reasons only, companies are going to follow this DevOps culture. It's not a new technology, it is not a programming language, guys. No, it is just a process that we are going to follow. Development plus operations is called as DevOps. It is used to simplify, it is used to speed up, it is used to automate our application operations, and we need to deliver our application to the client very quickly with a high quality. So that is the reason we are going to follow this DevOps. Okay, by following DevOps practices, we can deliver application to the client very quickly. Okay, development is doing the coding. So whatever the code is done by the development team, we need to perform the operations quickly on that code, and we need to deliver that code to the client as one application. That's where this DevOps practices comes into picture. That's where this DevOps culture comes into picture. Development plus operations, we are calling as DevOps. It is a process, it is a culture, it is nothing but set of practices that is used to establish the collaboration between development team and operations team. The main aim of this DevOps is used to simplify and automate and speed up application build and deployment process with a high quality application delivery process quickly. Okay, so by using these DevOps practices, we can simplify the delivery process, we can speed up, we can automate our practices. Okay, then how to adopt this DevOps processes, how to adopt this DevOps culture in our project. Okay, how to adopt this DevOps culture in our project, how to adopt this DevOps processes, DevOps practices in our project. Okay, by using set of tools, we can adopt this DevOps culture. Okay, by using set of tools, we can adopt DevOps culture. We can adopt DevOps culture in our project. Those tools are called as DevOps tools, guys. Okay, we are working in a project. We need to simplify the project operations. We need to automate project operations. We need to speed up project operations. So then how to speed up all these things? So that's where we are going to adopt. This DevOps culture. How can we adopt this DevOps culture in our project? By following set of tools, guys. Whatever the work that we do manually in the project, we are going to automate that work by using set of tools. That is called adopting this DevOps culture. Okay, so as a DevOps engineer, we need to create infrastructure in the project. As a DevOps engineer, we need to create infrastructure in the project. What is the meaning of infrastructure creation? One of the things that we need to do in the project, infrastructure creation. In order to run the application, developers are doing the coding. That code we need to run in one machine, right? So we need to set up a machine for that machine. Okay, so I'm taking one machine. So for that machine, we need to set up some storage. For that machine, we need to set up some network. For that machine, we need to set up some security. We need to set up some backup. Okay, so like this, whenever we want to run one application, we need to take a machine. For that machine, we need to set up lot of things: storage, network, security, backup, and all. So that's where infrastructure setup comes into picture. For every project, infrastructure is very important. So what is the meaning of infrastructure setup? Example, we need to set up machines for the project. We need to set up security for that. We need to set up storage. We need to set up network. We need to set up backup, etc. So that is infrastructure setup. So instead of we are doing this infrastructure setup manually, we are going to use a tool called Terraform tool. So using Terraform, we can automate. Using Terraform, we can automate infrastructure setup in project. Whatever infrastructure is required. So earlier, people used to set up the infrastructure manually. That is going to take a lot of time. So I want to speed up that process by following DevOps culture. So what we can do, we can use some tools and we can set up that infrastructure. Using Terraform, we can automate infrastructure setup in the project, guys. So this is one of the DevOps tool. So how to adopt DevOps culture? To adopt DevOps culture, there are set of tools available in the market. So if you learn how to use those tools, then you can adopt DevOps culture. Then you can simplify application delivery process to the client. So first thing, for every project, infrastructure is very important. Machines setup, security setup, storage setup, network setup, backup, restore, lot of things we need to do. Instead of we are doing that work manually, we can automate that work by using one tool called Terraform. So we should learn Terraform software. By using that Terraform, we are going to set up infrastructure required for the application. And the next one, as a DevOps engineer, in order to run our application, configuration management is very important. So nothing but here, I want to run my application in 10 machines. Okay, so I want to run my application in 10 machines. So if it is one or two machines, so easily you can install the required softwares and you can run your application. For example, there are multiple machines available that in those machines we need to run our application. Now in these machines, I need to install required softwares. So if I take one employee, to install all the softwares that are required to run my application, this person is called as a system administrator. I need to recruit one system administrator. That person will connect with all these machines and will install required softwares in these machines. I will recruit one person. That person is going to act as a system administrator and he will connect with all the machines and he will manage configurations in those machines. Today 10 machines available, that is okay. Tomorrow if I have 500 machines, tomorrow I have 500 machines. I got the requirement that I need to run my application in 500 machines. So can one person manage these 500 machines easily, guys? Can one person manage these 500 machines easily? No. So that's where it will take a lot of time. And he's a human. Humans can do the mistakes. He's a human. Humans are having some emotions. Humans are having some personal life. They have some personal problems. Okay. Their health conditions, their availability, their mindset, their stress. So many things we need to consider. Humans are having the emotions here. Humans are having the emotions here. Are you getting my point? So that is the reason. It is first thing, if human is managing all these machines to run my application, human is having emotions, human may do some mistake. So that's why it is not recommended to manage configurations. So what is the meaning of that configuration management? Install softwares, OS updates, transfer files, etc. All these things comes under configuration management only. So as a DevOps engineer, we are responsible to deploy the application in the computers and we need to deliver that application to the client. So to deploy this application in a computer, we need to install front-end software, we need to install back-end software, we need to set up database. So if all these softwares are installed properly in the computer, then only this software project will run in that computer. So if I want to run my project in a computer, then in that computer, I need to install Java software for backend. For frontend, I need to install React.js software. And for backend, I need to install Java software. And to run the Java software, I need to install Tomcat server. And I need to use the MySQL database. So if I install all these softwares properly in the computer, then only my application can run in the computer. If it is one computer, that is okay. I can install these softwares, I can run. But if I have 100 computers like this, in 100 computers, I want to run my application. Then we need to recruit one system administrator. That system administrator should connect with all the 100 computers. In all the 100 computers, he has to install these softwares. Then only our application can run in all those 100 computers. Can you guarantee that this person will not do any mistake in the installation process? He is a human, he is having some emotions. Can you guarantee this person will not do any mistakes while doing the installations? Can you guarantee he is very good person, cannot do the mistakes? We cannot guarantee. Humans means it's common that we will do mistakes in our life. So that is the reason I don't want to dependent on the human to manage my configurations. And if a human is doing, it will take a lot of time. So that's why I don't want to take this person to manage my machines. So then what I will do, I will use one software called Ansible software. Instead of a human, I will use one software called Ansible software. I will tell Ansible, hey Ansible, install Java in 100 machines. Very quickly, Ansible is going to install Java in all those 100 machines. Very quickly, Ansible is going to install Java in all the 100 machines. So if you give right instruction to the Ansible, Ansible will not do the mistake. Ansible is a software. Human can do the mistake, but a system cannot do the mistake. Remember that point. Humans are having emotions. Humans will do the mistake, but software will not have any emotion. System will not have any emotion. System will not do any mistake. So that's why instead of depending on the people, you need to depend on the systems. You need to depend on the process. Are you able to follow me? So if you want to create infrastructure manually, it will take a lot of time. So as a operations team member, we need to run the application. To run the application, we need machines, we need storage, we need a network, we need a database. So instead of we are doing that setup manually, we are going to use Terraform. Using Terraform, we can automate infrastructure creation. Then configuration management. In order to run our application, we need to install some softwares. Instead of we are installing softwares manually, we can take the help of a software called Ansible. Using Ansible, we can automate. Using Ansible, we can automate configuration management. Using Ansible, we can automate configuration management. Are you able to follow this? What is the purpose of Terraform and what is the purpose of Ansible? Could you please respond in the chat box quickly, all of you? Are you able to understand why we are going for a DevOps culture in the IT industry? Why IT industry is adopting this DevOps culture? IT industry adopting DevOps culture, why? IT industry adopting DevOps culture to simplify our application process, to simplify our application operations. Configuration management means managing the systems, installing the softwares. That is called configuration management. All right, next one. So here, source code management, guys. So in a project, multiple developers will be available and those developers will be working from different locations. Okay, infrastructure means Mr. Sri. Infrastructure means machine creation. Configuration means installing required softwares. By using Terraform, you are going to create a machine. You are going to create a machine by using Terraform. In that machine, software's installation we will do by using Terraform. You got the clarity? So if your doubt is not clarified, could you please unmute your mic and speak out? What is your question? So Sri, can you unmute your mic and speak out? I gave the permission to speak out. Sri, I don't know what's your full name. Sri, it's boy or girl, I don't know. So could you please?
Yes, sir.
Yeah.
Yeah.
What
Yeah,
is
just want to like basically infrastructure means creating the computer storage and
network?
operating systems, whereas configuration management means installing the software.
Correct.
Like, can you say Ansible is a configuration management tool, sir? Because you are creating the softwares.
Yes, that is what. Using Ansible, we can automate configuration management. Using Terraform, we can automate infrastructure creation.
Okay.
Your doubt clarified?
Okay. So infrastructure setup means only virtual machines creation, that type of activities, sir?
Yeah, virtual machines setup, database setup, security setup, network setup, that we will do by using Terraform. Once the machine is configured, once machine is created by using Terraform, in that machine, installing the software is nothing but configuration management that we will do by using Ansible.
Okay. What is alternative, sir? Terraform other than
For
Terraform?
Terraform, currently there is no alternate, sir. This is one of the trending tool in the market. It supports multiple cloud platforms.
Okay.
Okay.
Okay, sir. Thank you, sir. Thank you.
Good. For Ansible, earlier people used Chef and Puppet for configuration management. Those tools got outdated. Currently, Ansible is trending in the market. Before Ansible, people used Chef or Puppet tools for the configuration management. Now people are not using them. People are using Ansible currently. Okay, fine. Next one, source code management, guys. When we are working in a project, multiple developers will be available. Okay, project development team. Development means a set of developers will be available, team members will be available. Developer 1, developer 2, developer 3, and developer 4. 4 developers are available, and assume that these 4 developers are working from 4 different locations. One person is working from Hyderabad location, another person working from Chennai, another person from Pune, another person from Delhi. Okay, so like this, in our project, multiple developers are available, and those developers are working from different locations, work from home. Work from home. Those developers are working from different locations. And all these developers are working on the same project only, guys. All these 4 developers are working on the same project. Then this developer has done some coding, he has done some coding, he has done some coding, he has done some coding. So the project development is happening in 4 different locations. Okay, Hyderabad developer is available, Chennai developer, Pune developer, Bangalore developer, Delhi developer, like that. Our team members are working from different locations. They are doing the coding for the project. Now we need to integrate all the developers code at one place, and we need to monitor who is modifying the code, who has done which coding, who modified, when modified, what modified, where modified, everything we need to track. So if developers are working from different locations like this, then code management will become very, very difficult. Code integration will become very difficult. So the first problem that we are going to face here, how to integrate all the developers code at one place. How to integrate all the developers code at one place, that is one of the biggest challenging task here. How to integrate all the developers code at one place, that is going to be one of the challenging task in the project. Okay, so you are a DevOps engineer, you are responsible to take the code and deploy that code and deliver that code to the client. Can you go to Hyderabad and ask the developer to copy the code into pen drive? Then go to Chennai, ask the developer to copy the code into pen drive. Then go to Pune, take the code, go to Delhi, take the code, then come to your home in the Bangalore and integrate all the code and deploy that code in the server. Is it possible? Guys, is it possible to do like that, or it is not possible to do like that? Guys, is it possible to take the code manually and integrate that code manually? Is it easy? Is it possible, first of all? Come on, respond in the chat box. No. So here, when the team members, when our developers are working from different locations, the first problem that we are going to face is integration. How to integrate all the developers code at one place. Okay, and after integrating, tracking, code changes tracking. So some people modified the code. So whatever the code done by Hyderabad developer, that code is modified by Chennai developer. Why, when, what, where? We should be able to track the changes. Okay, code tracking is very important. Code integration is very important. So that's where we are going to use one software in the project, guys, that is called source code repository. What is that software, guys? We are going to use a software called source code repository software. We are going to use a software called source code repository software. If you set up source code repository software in the project, all the developers will connect to that source code repository and will integrate their code. So instead of you are going and taking the code from the developers, you will set up, as a DevOps engineer, we need to set up source code repository for the project. Then all the developers will connect to that source code repository and they will integrate that code. They are going to integrate that code. So when you go for this source code repository, it will provide you solution for these two problems, guys. Source code repository server will provide the solution for these two problems. You can integrate the code at one place and it will going to track your code changes also. So how to work with these source code repositories? It is DevOps engineer responsibility to set up the source code repository software for the project. Earlier, people used SVN for source code repository. Later, people started using GitHub. Nowadays, people are using Bitbucket. Either GitHub or Bitbucket, companies are using for the source code repository. Companies are using GitHub or Bitbucket for the source code repository. So code integration we need to simplify. Source code management. All the developers' code should be integrated at one place with a tracking. All the developers' code should be integrated at one place with a tracking. So that's where we are going to use GitHub or Bitbucket. We can use GitHub or Bitbucket as source code repository server. Okay. So instead of you are managing the source code manually, instead of you are tracking the changes manually, we can use GitHub or Bitbucket in order to integrate all the developers' code at one place, and we can monitor the changes. Who modified, when modified, why modified, what modified, all those things we are going to use. So nowadays people are using GitHub or Bitbucket or GitLab also. Okay, some people are using GitHub, some people are using Bitbucket, some people are using GitLab also as a source code management software. Right? Infrastructure setup automation with Terraform. Configuration management automation with Ansible. Source code management by using GitHub or Bitbucket or GitLab. And the next one. So as a DevOps engineer, we need to perform code review. As a DevOps engineer, we need to perform code review. So what is the meaning of this code review, guys? Before going to deliver our application to the client, we need to verify developers has done coding properly or not. So for that, we need to perform code review, guys. So to identify mistakes in the source code, to identify developer mistakes in source code, we will perform code review. So developers are doing the coding properly or not, developers are following best practices or not, we are going to identify by using code review. This is also our responsibility. Okay, we can use Sonar Cube to perform code review. Instead of we don't know coding, we cannot go and check whether that code is correct or not, because we are not from programming background. So we don't know whatever the programs created by the developers, they are correct or not, they are following best practices or not, are they doing any mistakes in the coding, are they writing the same code again and again, duplicate code is available in the project. Those things we can't identify because all the DevOps engineers not from the programming background. So that's where there is a tool available in the market that is called Sonar Cube. Sonar Cube is used. We can use a Sonar Cube. We can use Sonar Cube software to perform source code review, to perform project code review. Okay, so as a DevOps engineer, we are responsible to perform code review also. To perform the code review, we are going to use one software called Sonar Cube software. We can use this Sonar Cube to perform project code review. So following all these practices, that is called DevOps. Okay, developers are doing the coding, right? then we are responsible to deliver that code. So before going to deliver that code, we need to perform some operations. So with these operations, we can speed up the delivery process. Okay, infrastructure setup manually will take lot of time. Configuration management manually will take lot of time. Code integration manually will take lot of time. Code review will take lot of time. So that's why we need to simplify that process. We need to automate that process. That's where we are using DevOps culture. So there are several tools available. If you implement these tools in the project, that is called a DevOps culture. Nowadays, every company, every project is following this DevOps culture to simplify application operations, to automate project operations, to speed up application delivery process. Now, IT companies are adopting this DevOps culture. So now, if you want to work as a DevOps engineer, you should know how to automate all these operations by using set of tools. The tools we are using to perform operations on the project, those tools are called as DevOps tools. Infrastructure setup, for that Terraform. Configuration management, for that Ansible. Source code management, for that GitHub or Bitbucket or GitLab. Code review, for that SonarQube. For code review, we are using SonarQube. Are you able to follow me? Then next one, project build process. Project build process. Project build. Project build. Convert the source code into, convert project source code into executable form. Convert the source code into executable format. So for example, Java people will give you .java programs. Java people will give you .java programs. We need to convert those Java programs into jar file or war file for execution. If you go for .NET programs, they will give you C#, they will give you C# programs. Okay, to run that C# application, .NET application, you need to convert that C# programs into DLL file. Java programs should be converted into jar file or war file. C# programs should be converted into DLL file. So that's where project build process. Developers will write the code. Directly we can't execute that code. So we need to convert that code into executable format. Okay. Developers will write the code and the developers will keep the code in the GitHub repository. So we need to take that code from the GitHub repository and we need to convert that code into executable format. We need to convert that code into executable format. So to convert our code into executable format, we are going to use build tools, guys. We are going to use build tools, right? Python programs directly we can run. For Python programs, build process is not required. For Java, for .NET, for Angular, for React, build process is required. Python is a scripting language. For Python, build process is not required. Are you able to follow this? Now, here, to convert this project to source code into executable format, the build process is required. So we can use Maven or Gradle to build Java projects. Okay, we can use MS Build to build .NET projects. We can use MS Build to build Java projects. Okay, we can use NPM Node Package Manager. We can use NPM to build Angular or React projects. So like this, there are several build tools available in the market in order to convert our project to source code into executable format. So that is build process. Doing the build process manually very difficult. So we need to automate that build process. So to automate that build process, there are several tools available. If your project is Java, then you can use Maven or Gradle to build your project. If your project is .NET, to build .NET projects. Okay. If your project is .NET, then you can use MS Build. If your project is Angular React front-end application, then you can use npm to build those applications. So these all are the operations we are converting. Okay, so directly Java code cannot execute. Developers will write the code. Okay, suppose for example, if I show you GitHub repository. So in my GitHub repository, there are so many Java projects are available. For example, let me open one Java project. So this Java project is there in the GitHub. Code is available in this Java project. So SRC, nothing but source code. So if I give that code, if I give this code for you, can you understand anything? This is my Java program. Can you understand this Java program? Can I give this to you? Are client, man. You are a client. You gave a requirement for me to develop the project. I have done the coding by using Java. I have done the coding by using Java. So if I give this Java program, that Java program, can you use this Java program? Can you use this Java program? Someone is asking why we need to perform build process. The reason is developers will write the code and will give the code like this. Can you give this code to the client? Can you give this code to the client? Can I give this code to the client? Client cannot understand. For client, what we need to do? We need to convert that code into one executable application like this. If I give application like this, client can use it. If I give the code like this, client cannot use it. So that's where we need to convert that code into executable format. Project build process. We need to automate the project build process. We need to automate the project build process. So how to automate the build process? For Java projects, jar file or war file we need to create. For C Sharp, DLL. Okay. So for Java projects, which build process tool is available? Maven Gradle we can use as build tool for the Java projects. For .NET projects, MS build tool is available. Okay. For Angular, for front-end applications, NPM build tool is available. For Python projects, build process not required. Python is a scripting language, build process not required for Python projects. Okay. Python is a scripting language, build process not required. But for Java, .NET, Angular, React, build process is required. Are you able to follow me? So these all are operations, guys. These all are operations. So we need to automate these operations. So that's why DevOps comes into picture. Developers are there, operations team members are there. So that is the reason we are telling that DevOps is used to establish collaboration between development team and operations team. Development team will focus only on writing the code. That's it. Developers will focus only on writing the code. Then we need to focus on the operations. We need to create infrastructure for the project. We need to install required softwares to run the application. We need to take care of the code integration part, and we need to perform the build process, and we need to take care of the code review. We need to take care of the code review, and we need to identify mistakes available in the code. What mistakes developers has done in the code that we need to identify here. What are the mistakes done by developers in the code? We need to identify those mistakes. So for that, we are going to do the code review. To do the code review, Sonar software is available. Okay, these all are operations. So if you are performing these operations with automation, that is called DevOps practices. So instead of spending hours of time, we can complete these operations within fraction of minutes by using these tools. These tools are called DevOps tools. These tools are called DevOps tools. Okay, guys. Next one. After code review is completed, then application deployment. Application deployment in a server. So to run the application, server is required. To run application, server is required. Example, for Java, we can use a Tomcat. For .NET, IIS. So if your application is a Java application, Tomcat server. If your project is a .NET project, IIS server. If your project is Angular or React, Nginx server. So like this, there are multiple servers available. Depends on the project technology, you are going to use particular server. Okay. Suppose if your project is Java project, Tomcat server for Java applications. Tomcat server for the Java applications. IIS server, IIS for .NET applications. Okay. And Nginx server for Angular or React. For front-end applications execution, Nginx server we are going to use to deploy. For Java applications, Tomcat server. For .NET applications, IIS server. For front-end applications, Nginx server we are going to use. For application deployment purpose, we are going to set up the server. For application deployment purpose, we are going to use the servers. Application build and application deployment. So developers are writing the code. That code they will store in the GitHub. Let me show you one diagram. Here developers are writing the code. Developers code will be stored into the GitHub. Then we need to take the code from the GitHub. We need to build that code by using Maven. Then we need to deploy that code into the Tomcat. Build and deployment process. Build and deployment process. So development team is available. They are writing the code. Developers will store that code into GitHub repository. Then we need to take the code from the GitHub. We need to build that code by using Maven. We need to review that code by using Sonar. And finally, we need to deploy that code into server. So if you are doing this work manually, it will take a lot of time. So that's where we will give the task to Jenkins. Instead of we are doing that work manually, we will use build and deployment automation. Okay, CI/CD, continuous integration, automate build and deployment. Build process with Maven, deployment with Tomcat. But who will do the build and who will do the deployment? Instead of we are doing the build and deployment manually, we are going to automate that build and deployment. Automate build and deployment. That is CI/CD, continuous integration and continuous deployment. Continuous integration and continuous deployment, guys. We can use Jenkins to automate this process. So we can use Jenkins. We can use Jenkins to implement, to achieve or to implement CI/CD in the project. We can use Jenkins to implement CI/CD in the project. What is the meaning of CI/CD here? Continuous integration and continuous deployment. So that means whenever developers modify the code in the GitHub, immediately we need to take the code from the GitHub. We need to build that code by using Maven. We need to review that code by using Sonar. We need to deploy that code into server. If you want to do this work manually, it will take a lot of time. So that's where I want to automate that work. I want to automate that work. So that's why we are going to use Jenkins in the project. We are going to use a Jenkins tool to automate project build and deployment process. Continuous integration, continuous deployment. We can use Jenkins to implement CI/CD in the project. When the code is modified in the GitHub, immediately take the latest code, build the code, review the code, deploy the code. That's it. So everything will happen within fraction of seconds. Everything will happen within fraction of seconds. If Jenkins is not available, then to do this build and deployment, it may take 1 hour time for us. By using Jenkins, we can complete in 1 minute. So 1 hour time we can reduce to 1 minute by using this Jenkins. So this Jenkins is a CI/CD software, continuous integration and continuous deployment. Whenever there is a code change, immediately we want to do the deployment. Whenever there is a code change, development team is available. Developers will write the code and they will add that code, they will integrate that code in the GitHub. Then immediately we need to take the latest code and we need to build that code. We need to review that code. We need to deploy that code. So that is the build and deployment. So if you do this build and deployment manually, it will take a lot of time. Then how to automate build and deployment? By using CI/CD. What is that CI/CD? Continuous integration, continuous deployment. Okay, next one. So monitoring. After build and deployment is completed. Okay, so we are going to monitor our applications. Monitoring. Monitoring is very important. So infrastructure monitoring, application monitoring. So infrastructure monitoring. That means how our infrastructure is working, how our servers are working, how our database is working. That we need to monitor. And the second one, application logs monitoring. Infrastructure monitoring, application logs monitoring is also required. So infrastructure monitoring, nothing but how servers are working. Is there any problem with the server? Is there any memory issue with the server? Is there any burden on the server? Infrastructure monitoring we need to do. Application monitoring also we need to do. So to do the infrastructure monitoring, we are going to using Grafana and Prometheus. Using Prometheus and Grafana, using Prometheus and Grafana, we can monitor infrastructure. Using Grafana and Prometheus, we can monitor our infrastructure, our servers. We can monitor our servers. Servers monitoring. Using Prometheus and Grafana, we can monitor our servers, how they are working. Application logs monitoring. Using Splunk or ELK, we can monitor application logs. Using Splunk or ELK, we can monitor application logs, guys. So all these things we are going to automate. That is called DevOps. So by learning all these tools, we are going to automate all that work. So what is the meaning of DevOps now? Can you tell me? What is the meaning of DevOps now, guys? DevOps means development plus operations. DevOps means development plus operations. So this DevOps is not a programming language. DevOps is not a new technology, guys. It's not a programming language. It is not a technology. Then what is this DevOps? It is a culture. It is a process. DevOps nothing but it is a culture. DevOps nothing but it is a process. Now companies are following this culture or companies are following this process. Companies are following this process to simplify our operations in the project. Companies are following this process to simplify these operations in the project. Able to follow me? So development team will be available, operations team will be available. Development team will write the code. Development team will write the code. So we need to perform operations, okay? And we need to simplify the delivery process of our application. Okay, so in the real time, how the operations will be automated, I'm going to show you with one diagram. 1 minute, guys. It is in my another laptop. I'm taking that. I will show you in the real time how those operations will be automated. What is the final agenda that we are going to get here? Give me 1 minute. I'm getting that from another laptop. Sent it to my email. Yes. So these are the DevOps tools that we are going to see. So in the real time, how we are going to automate that complete process. How we are going to automate this complete process, I will show you here. Now you see. So development team is available. Can you guys see this image now? Can you guys see this image now? Yeah. So developers will write the code and they will store the code in the GitHub. Jenkins will take that code and Jenkins will build that code by using Maven. Jenkins will build that code by using Maven. Then it will use some Ansible to perform the configurations and it will talk to the Docker. Then it will create the Docker image. It will store the Docker image into Docker Hub. Then final deployment will happen. Our final application will be available in the Kubernetes. So the application will be deployed finally in the Kubernetes. Docker, Kubernetes are very, 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 very important. What is in this entire course, Docker, Kubernetes, Terraform, Ansible, Jenkins, these are very, very, very important. Okay. So where this Docker Kubernetes comes here in the build and deployment process, in the build and deployment process only that a Docker comes into picture. In the application deployment process, using Docker and Kubernetes, we will run our applications, guys. In the deployment process, to run the applications, we are going to use Docker and Kubernetes. We will use Docker and Kubernetes for application deployment. For application execution or for application deployment purpose, we are going to use Docker and Kubernetes tools. Docker and Kubernetes tools we are going to use for our application deployment process. Jenkins to automate the build and deployment. Okay, so I hope now you got the clarity on the operations that we need to perform on the project and what are the tools that we are going to use. So mainly here, Terraform for infrastructure. Then next, Ansible for configuration management. So third one, GitHub or Bitbucket or GitLab. Okay, and the fourth one, build tools. Maven, we are having Gradle, we are having, and MS Build we are having, and NPM we are having. They based on the technology, the tool is going to change. Then next one, SonarQube, which is used for code review. And the next one, Tomcat or IIS or Nginx, based on the technology. Then next one, we can use Docker and we can use Kubernetes here and to automate the build and deployment process. Okay, we are going to automate that by using Jenkins and Prometheus and Grafana for our application monitoring, servers monitoring and logs monitoring. For logs monitoring, Splunk or ELK we are going to use. You got my point? So if you learn all these tools, then you are going to automate operations. You can simplify operations. Okay. So here SonarQube will be available and Nexus also will come. Nexus purpose artifact upload, guys. Artifact upload. So whenever we build our Java project, jar file or war file will be created. To store the jar or war for backup, Nexus we are going to use Artifactory server. Okay, after build process is completed, here we can say Artifactory server. Artifactory servers to store project build artifacts like jars, wars, DLL files, etc. Okay, so any jar or var that we are going to use, right? So that jar file or war files we can store in the artifact. So we can use Nexus or JFrog. We can use Nexus or JFrog to store project artifacts. To store project artifacts. We can use a Nexus or we can use a JFrog to store project artifacts. Right? Infrastructure setup, configuration management, source code management, project build process, and artifact storage, code review, application deployment, and application automating the build and deployment, application monitoring, logs monitoring. So all these things we are going to perform by using several tools available in the market. Those tools are called as DevOps tools. DevOps engineer, nothing but you should know all these tools. You should work with all these tools in order to automate the project operations. Development team plus operations team. The collaboration between the development team and operations team is called DevOps. I hope you got the clarity. Yes, very good. Good guys, fine, thank you. So our day 3 session completed successfully. Tomorrow we are going to understand about the life cycle. Tomorrow we are going to understand the life cycle of the project life cycle, and where this DevOps tools comes into our project life cycle, that we are going to learn in the tomorrow session. So as of now, we discussed about what is a software project and why software project, and project architecture, project teams, and what are the roles and responsibilities of operations team, what is the DevOps, and what we need to do to adopt DevOps culture. So if I want to implement a DevOps culture in the project, what are the tools we need to use, and what is the purpose of each tool that we understood. Okay, so with this, I'm stopping for today, and I will be sharing this video in the WhatsApp channel. Anybody who is not part of the WhatsApp channel link I'm giving in the chat box. So please click on the link and follow that channel so that you will not miss any update. And this class notes also I'm going to upload in the Zoom chat so that you can download it. I am uploading the notes in the chat box. If you join from your system, then you can download it. Okay, now I will take the questions. I will answer. If you have any questions, you can unmute and you can ask your questions. So before that, all of you able to download the class notes I sent in the chat box? Yes, very good. Thank you guys. Thank you. So we will meet again tomorrow at same time. Tomorrow we'll understand the project life cycle and where DevOps comes in the project life cycle.